You guys see me? Hi. Hey, RJ. Nice to see someone that's not a black square. I spent my weekend complaining about talking to black squares. You guys are all awesome personalities, but the black squares, kind of rough. Can't get any feedback. Got a good group this morning, it looks like, so far. I know it's getting harder and harder for everybody, I can tell. Hey, Sonny.
Is that better?
I can see ya. Yeah, it's just we just don't have the bandwidth to see everybody, so I understand. It's just a bunch of black squares, so no feedback.
I think it does pretty good. I think it's a VGA. It looks about Windows 98 old. I found it in a box in the attic.
It looks pretty good. It looks fine. I think it's working. A lot of people don't have cameras, so I don't really need it. I don't use it very often. I'm going to shut it off. You guys know I'm here. Hey. Video out. Everybody else is so quiet. I'm going to share my screen. We have so much going on right here at the end. This is our second to last week, you know. Oops, gotta move that out of the way. Can't shut it. So first thing I wanted to look at that exam that everybody took last week. We can see we had some low scores bring down our average. Those could be people that aren't coming to our Zoom sessions, do you think? Also, I have not actually graded it, so there are some ungraded answers. So probably everybody's scores will go up when I get that done. I apologize. It seems like with this stay at home and everything remote, just kind of not, I don't know. It's interesting. It seems like you should get more done, but yet it's hard to. So let's take a look at the questions that are graded and see what we've got here. I see some that went really, really well, and some that we should look at. First of all of these random questions, the rule is that a random number is going to be between 0 and 1. I'm sure you saw that in your book. It's going to be some sort of decimal value. So anytime we look at these kinds of problems, we know that random is going to be some value, a decimal value between 0 and 1, a float. So if I said that it was 0.01 times 4, then plus my number, that would give me my number, right? So a really low value for random would result in basically a 0 when we multiplied by 4. So our result would be our number. Now, on the other hand, if our random value came back as near 1, like 0.99, when we multiplied it by 4, what would we get? Should we try the calculator? Let's do it. Talking math so hard. So if we had 0.99 is the result of our random number, and we multiplied that by 4, it would give us 3.96. And we use the floor function. Now, if you remember what the floor function does, it basically just chops off the integer part of our value. So we would end up with a value of 3. Do what?
Oh, chops off like the float part.
Right, the float part. Exactly. So that would leave us a value of 3 when we added that to our number of 6, or sorry, of 3. That would give us a value of 6. And that question is kind of messy, but there's that 6 right there at the beginning. So you can kind of get the pattern of what's going on with all of these questions that have to do with the random number. And I think using the calculator is a really good plan to kind of get it straight in your mind. It rounds down. It just chops it up, doesn't it? It's a really liberal definition of rounding. Okay, and then on the next one, we're talking about the ceiling function. Now, I wanted to remind you, we did last week this built-in functions program where we just quickly ran all of these different functions so that we could validate what each of them did. So here's the section where we're doing the ceiling function. So we're giving it values of 10.2 and 10.6. If I run that, we see that ceiling always kind of takes it up to the next integer value. So kind of like where floor doesn't really round, it truncates. Ceiling doesn't really round, it just rolls up. Is that a good way to put that? So our different functions can give us different results. So if we do a ceiling on this value, the result is going to be 5. So good job. Everybody got this one right? When we start with an integer, we're going to end up with the same value if we call the integer function. This one is going to be one that I need to grade. The starting value of an algorithm used to generate a range of numbers is called the seed, or the seed value. Another one of the random number ones. Now, these code snippets, and these are pseudocode snippets, so they can be quite difficult to decipher when you're taking an exam. So I guess my recommendation would be, get a blank piece of paper, a piece of scratch paper, and use it to write down notes if you need to as you're evaluating the code. And just take it slow. Don't try to rush yourself, because that's where we make careless mistakes, and that's what the test is kind of looking for. So on this one, everybody did really, really good. Let's see how this goes. We have two integers, g and h. We start with g and a value of 7. While g is less than or equal to 8, we're going to change the value of h to 6. Then while h is less than or equal to 7, we're going to write out the value of the sum of g plus h. So the first time through our loop, sometimes that can help if we just figure out what the result is going to be the first time. G will be 7, h will be 6, so we will write out 13. So if I look down at the answers, I already have eliminated a couple, right? It has to be A or D. Now, if I continue on with the code, I'm going to add to h and re-evaluate my h loop. H will be equal to 7, so I'll execute the loop again, write out the value, which will be 14 this time, add to h, and that will end my inner loop, right? So since my inner loop is over, I'll add one to g. So g will now become 8, and my while loop will execute one more time because g is less than or equal to 8. Now when my while loop begins executing, I'll set h to 6 again. So my output is going to be 8 plus 6, or 14. So that means that the right answer has to be D, because it repeats 14. Now, as a test-taking strategy for software development, only continue on with that loop and with that logic if you need to be sure of the right answer, or if you need to satisfy yourself that you've got the right answer, you know what I mean? But as a software developer, you know that at that point you can stop desk checking that code, stop walking through it, because you know you've got the right answer. This one, not too bad. If number is 2.7, now are we looking at a true or false statement? Well, on this side of the condition, we're going to end up with an integer value because we're using the int function. And on this side, We are not, because we have floats that we're multiplying, so they cannot be equal. So I don't need to do the math, right? I can tell from the syntax. Okay, this next one did throw some people. If one for loop is nested within another, then the limit value for the two loops must be different. Well, now we know that's false because we wrote some nested for loops ourselves that had like a limit of 10 on the outer loop and a limit of 10 on the inner loop. So we can use that same value as much as we want. Now, if it said the same variable, then we might be looking at a different story. But since it's the same value, sure, we can do that. Looks good on this one. So in this example, again, we're working with an integer and a float, so they're not equal. So remember the one above where we did multiplication? Exactly the same. Just trying to throw you with some math. All right, and again, another code snippet. Here we're starting out again with an integer named a and a float variable named b. We set a to 2, and we go into a while loop. While a is less than or equal to 3, which it is, we're going to set b equal to 2.5 times a. Well, a is 2, so that means b is going to be equal to 5. So I'm going to write out that answer of 5. So again, I'm going to look at my possible test answers, and they weren't quite as nice this time. We have 3 possible answers where the first number output is 5. Now I'm going to change b to be an integer value and write it again. So now I know that I've got 5 followed by 5. Again, we have 2 possibilities. We're narrowing it down. Now we're going to update the value of a by adding 1. So now a is going to be 3. It's still less than or equal to 3. So I'll continue on. I'm going to multiply 2.5 times 3. So does that give me 7.5? So now I know my right answer.
Someone's entry slope.
Do you have a question, Vincent? Does that make sense?
Yeah, it makes sense.
Okay. Now this one threw people. It is not possible to put a loop inside an if-then statement. Sure it is. We can have a loop inside of an if statement. We could have a loop inside of a loop inside of an if statement, inside of a loop. So we can put that code however we want. Trick question. What about this one? This one is some math. They're saying my number is 7.82, and I'm going to divide that by 2 and then convert it to an integer. Then I'm going to add 0.5 to that integer. Again, if I do like process of elimination, I know that I'm going to end up with a number of something 0.5, right? So my only right answers are this second one and this last one. Now, what is the right one though? Well, let's see, 7.82 divided by 2 is going to be 3 point something. I'm going to chop off that point something, right? Because I'm converting it to an integer. So my answer is 3.5. So am I doing some shady math? I am, because I'm trying to find just the troubleshooting, just the stepping through it enough to know which answer is correct. Because if, do I?
Good question. So for clarity, when converting a float to an integer, it essentially performs the same operation, or at least will give the same result as using the floor command, correct?
Yes, yes.
Okay. It just truncates the decimal.
Just truncates that float part right off. So there's no float left. And I don't know why we have two functions. I'd say one came through in one library and another in another library. We just ended up with two that kind of do the same sort of thing. Ceiling and floor would be considered more math functions, where the int function is really casting a number as an integer.
Isaiah is mentioning in the chat what happens with negative values. I guess that would make sense with, he says the floor rounds down when a negative value is passed, but the int rounds up when the number is negative.
Let's look at that one again. So here's our floor. We don't have any that do the int. Let me copy these. Just take a second. Where is my replays? See, I have a few more. Run that. Oops. Like I said, int is not in the math library, so let me get rid of that specification here, because int is more of just a casting, like I'm going to make something that's not an integer into an integer, so it's not really considered math. So I think that's where we're seeing that difference, right? So if we look at our floor, which I split up, sorry, for our positives, like Isaiah's saying, it just chops off that decimal place. But for our negative, the absolute value increases.
That makes sense because the floor goes down, and while 11 is bigger than 10, negative 11 is smaller than 10. So you are still going to a lower or smaller value number.
And whereas the integer function just chops off the decimal place irregardless.
So int truncates. So for absolute values and positive values, they'll perform the same thing. But if you're expecting negative values, then you need to be mindful of which one you're using and what you want to achieve there.
Yep. Good research. So a lot of these detail items will only be on, some of your beginning programming exams, because they want you to really, have clarity on some of these concepts. Okay, this one. Good job. We can nest whatever kind of code we want to within a for loop. So there are no restrictions. Anytime you see a question like that, there should be no restrictions. Now we have, again, another one of the random type things, and I think this is the one, isn't it? RJ, is this the bad one?
It would help if I unmuted. Okay.
Is he not here? There you are.
I don't think, no, that one's not the bad one.
This one's okay. Okay, there is a bad one. When we find it, I will identify it, and it's one that everybody will get the points for. I didn't get it deleted before we had the exam. So again, in this one, pull out the calculator. If I have a random value of 0.01, I'm going to end up, in this first part of my calculation. When I use the floor function, I'm going to end up with a value of 0, adding 5. When I have a random value of 0.99, and I use the floor function on this formula, I'm going to end up with a value of 4.
It
So I
is
don't
the
know.
incorrect one.
Huh?
It
So
is incorrect.
it
Yeah,
seems
I
like
think,
the incorrect one.
yeah, my mistake. I think that is the
Okay,
one.
so
Now
this,
that I look at
this
it again.
10 should not be in here. So if this one is kind of thrown you, I apologize. This one sneaked by, and we'll get everybody the points for that one. So that would be the closest answer. Give everybody freebies on that one. Now this one, we only had a few people that got it. And this one is kind of a weird one because it's a language feature that we don't really see much anymore. But in older programming languages, you could set the function name equal to a value, and that would be the same as saying return this value. So if my function name were add it, I could say add it equals 47, and that would return the value 47 from that function. So I'm glad not very many people got this question. It's kind of an out-of-date feature, unless of course you use a language that uses it, then you think it's just completely current. So that one is true, but it's not something that's used often. Here's our add it function. Speaking of that, we have this function named add it, and we're looking at pseudocode. And all this function does is return, because it sets its own self, its own name, equal to x plus 15 divided by 2. So let's not worry too much about the syntax here. What's going to happen with the math? When we divide 15 by 2, because we're doing integer division, right, we're going to get 7. Is that right? Or are we going to get 7.5? According to our test, we're going to get 7.5. We're passing in a value of 4 that we're going to add to that 7.5. So that's going to give us 11.5. Good job. Another one that hasn't been graded. This process is recursion. Code snippet. We're setting X, Y, and Z to values. We're calling our subprogram numbers with the values X, Z, and Y. We've not done that in order. And then our subprogram is receiving those values as A, B, and C. So what we're going to write out is 15 for our value that started as X, 20 for our value that started as Z, and then 25 for our value that started as Y. Good job on this one. For built-in functions, like all of those math functions, we had to use our math library to access those. We did that with the import statement in Python. Great job on this one. Shirt, shoes, and pants. A lot of people that got it and got it correctly. Now this one does a division and does return an integer value. So if we start with 9, divide by 2, we get 4.5, and then convert it to an integer, we're going to get 4. So in this test question, they put in some distractors, right? That's what I would call it. So because returning by using this function name is kind of weird and kind of obsolete, they put that code in to kind of be a distractor. Well, what's going to happen here? Is it going to do something? I don't see a return statement. Is this normal? And the distractor was to make us worry about all of that, when in the end, what really mattered was that we were going to convert the result to an integer. So we lost that decimal. So I like to tell everybody to really focus on the parts of the question that you're comfortable with, because most of the time, that's where the actual answer lies. The extra information is distractors meant to kind of throw you just a little bit.
College is rigged on purpose.
Do I?
College is rigged on purpose.
Yep. It's like, no, you could think of something else. All right, here's one where we've got just an integer, but it is a negative. So in this one, again, that little detail is what can get you. The value of int negative 35.8 is 35. No, it would be negative 35, right? Because the int function would not change that sign. So that's why that one's false. Another one that I'll need to grade. Yuck. If data in the main program is needed by a subprogram, the value of that data is passed to or imported by the subprogram. And I'll be pretty generous with that one. Some people will say input by. Our textbook likes that imported term, but I'll take either one. The part of a program in which a given variable can be referenced is that variable's scope. Remember, if it's a global variable, its scope is our entire program. If it's a variable that we declare within a subprogram or a function, its scope is only that function. We can't refer to it outside of that function. Programming languages usually supply an assortment of built-in functions. Code snippet here. We have pretty good results on this one. We have a function. There's no indentation, so that can be a little bit off-putting when we're used to Python with our indentation. But we're taking the sum of a number, n, that's been passed to us. Oh, that looks like that recursive one. What's our problem here? Where is the code that is recursive? The recursive part is where sum calls itself. So here we see update sum by calling sum again. So that's why line 5 is the recursive statement. Okay, in this one, we have our word bunny. We have a counter that's an integer. We start with it at 1. While it's less than 5, we're going to do some stuff here. What are we going to do? If our counter divided by 2, and then using the floor function, so basically taking the integer value, equals our counter divided by 2, so leaving the float value. So what are we saying there? It's an even number. If it's an even number, then we're going to set the word to uppercase, otherwise to lowercase. So the first time through, we should set it to lower, right? There we go. The second time through, we're going to add 1 to count. Now when we divide, they should equal, so we'll set it to upper. Add 1 to count. Next time through, our count is going to be 3, so they will not equal, so we'll go to upper. So we can see we're alternating back and forth. Odd, even, odd, even. So that one got like half the people that took it. And sometimes when you look at code like this, when you're taking an exam, you're just like, I don't know. That's where you have to just stop and think about it. Parameters, as well as arguments, these are the values that are passed back and forth between calling programs and the subprograms, can be constants, variables, or general expressions. They say that's false because a general expression is not something that can be passed. What is that? Let's go Google it. I'm getting all sorts of regular expressions, not general expression. Here's one that's sort of math-like. So the general expression is more of a calculation, a formula type thing. So that's not something that we could necessarily use as an argument when we're calling a function. So it's a word that they thought would sound right, which it does, but it's not really a thing to us in programming at this point. And here we have some pseudocode. Again, we're doing some different calling. In this snippet, we have a value r, a variable r, that's an integer, and we're going to call our display function using r times 6, so that value of x would be 12. I see that's going to be the first thing output, so it has to be one of those two. Then I'm going to add 1 to r, so it would be 3. And I'm going to print y last, so don't worry about it. And then lastly, the value of 14 will be z. So I don't know. What do you think? I think I've given everybody points for that one. Yay, loops can be nested. You're right. Yeah, this one up here, I'm giving everybody points for. It's just not comfortable. All right, what about this one? A counter in a loop can count up by 5s. Yes, it can, we know that. How about a select case statement? Oh, yeah, you remember? We can do those in pseudocode, and we can do those in other programming languages, but we can't do them in Python. So those are those things that are hard to remember. But most of these type of questions, yes, it is possible. We can have a select case in an if structure in a single loop. Another one like that, a for loop may not be nested. That's false. We can nest them. Again, watch those knots. A counter named myCount in a for loop has a value of 5 on the first pass, 10 on the second pass, 15 on the third pass. The increment would be written as, well, this one is difficult because we are looking at pseudocode in our textbook and we're looking at Python code in our programming languages. So I'll take a lot of variety here is an answer to this one. Something like myCount plus 5 or plus 5. A lot of things will be acceptable. In this one, if a counter named myCount in a for loop has the initial value of 5 on the first pass, and we want it to go through 4 iterations, increasing its value by 5 on each pass, the test condition would be written as myCount. What do we want it to be? Less than or equal 20. Would that be right to go 4 passes? In a program with nested loops, the inner loop is completed before the outer loop. That's true. Again, another one where we're just trying to get some details here. We have nested for loops in this example. And what I would do, again, is have a piece of paper beside me, and I would write down y equals and set its value. And I would write down x equals and set its value so that I could refer to my notes as I went through the code snippet. So the first pass, Y is going to be 1, X is going to be 3. So I would write out the value of 3. So it's either A or D. Both of these loops increment by 1. So the next time through, Y is going to be 2 and X is going to be 4. Is that right? No. Look at me trying to confuse you. We've got to keep running our inner loop. So Y is going to stay a value of 1. So when X becomes 4, Y will remain 1. So we would print out a value of 4. Now at that point, we will fall out of our inner loop, go back up to our outer loop, and now Y will become 2. X will become 3 again, and we'll write out a value of 6. Then we'll add to X. So Y will remain 2, but X will be 4. Write out a value of 8. So this one just has like weird spacing. They're basically exactly the same, except for that weird spacing. So good job on that one. When a subprogram is called, the values of the arguments are assigned to corresponding parameters. Again, I'll grade flexibly. A variable that is declared outside all program modules, including the main module, has global scope, right? That's where we declare those global variables. Look at all of these 100%ers. Skip past it, take us forever. If a data item which is processed by a subprogram is needed by the main program, its value is imported to the main program. That's false because it's exported to. It's returned to the main program, not input by. Okay, and everybody got the apples and oranges perfect. A function that converts a number X to a corresponding string is the str function. When a variable is passed by blank to a submodule, that submodule receives only a copy of that variable. That's when a variable is passed by value.
Can you explain that one?
You can look at the video from last week because we explained it in quite detail. So I would definitely refer you back to that.
Okay, I'll go over it.
Yeah, because it is important because in that video we talked quite extensively about passing by reference and passing by value and the recursive program function. So those are important things to review if you weren't able to be in that Zoom session. Now the next snippet here, we're again doing a loop, but we have a bottom controlled loop because we're repeating all of this information until we get to a certain value. So in this one, we have P and M both as integers. We start with M with a value of 2. We set P equal to 1 as we go into our loop. While P is less than 4, we're going to write out the value of M, the word and the value of P. So I'll have 2 and 1 the first time through. I'm going to add 1 to P, so P is going to be 2 now. I'm going to execute my while loop again. P is still less than 4, so this time I will write out 2 and 2. Almost lost it there. I'll add 1 to P, and I'll write it out again, and this time it will be 2 and 3. So good job. Another one of the random value ones. Now in this example, we have, again, a code snippet. We have a count and a sum. And so with our sum, we want to start with it at a value of 0, and we're going to use it to add all of the values of our counter to. So we're going to end up, right, with the values of the numbers from 1 to 49 in our sum. Now we wouldn't get 50 because we stop our loop when our count becomes 50. Good, good, good.
I've never seen that format of for loop before.
This one up here. This format is kind of what they show in our textbook for the pseudocode. So it's what you'll see in C# and in Java. So it's just like our Python loops. It's just in our Python loop, we only have the numbers. So in our Python for loop, we would have, you know, within parentheses where we were specifying our values for our looping, we would have 1, 50.
And I typed in the chat the format that we were taught.
Uh-huh. So what about, could you do it would be 1 like that in the chat. So it would be the range type for loop where we can set up our range values with our beginning value, our ending value, and then our increment. But it is definitely different, and it is a very different syntax. And I appreciate that you guys have had to deal with that being so different. And I don't know why our textbook uses that syntax other than it's what's used in C# and Java. So at some point, I guess, they felt like it was the most popular syntax, but it can be very confusing. So it's just a different way to specify those range values. So actually, the for loop we would have would be for count in range 1, 50. And that would be exactly the same because we didn't to use the variable name count. But yeah, that syntax is something that you'll see as you get into different languages. But it can definitely be inconsistent. Oh, you guys got the widgets, you've got all that down. Another one of those random ones. Go through some of these with the calculator because they're going to show up on your final. Functions that are program modules created by the programmer are called built-in functions. Nope, those are user-defined functions. Built-in are the ones that come with the language or with those libraries. Let's see this one. Oh, this one got a few people. Let's take a look at it. Here we've got A is a float and B is a float. We're going to start out with A equal to 4 and B equal to 20. Then we're going to call our math function passing A and B. And then when we come back from our math function, we're going to write out B divided by A equals B divided by A. So in our math function, what's important here is that same old thing, that passing by reference. So when we normally pass variables, we pass by value, right? In this example, they've used this as ref keyword, and they're saying, we are not passing this variable by value, we're passing it by reference. We're passing the memory location so that this subprogram is working on the exact same data
Passing as a
in
reference
memory.
possible in Python.
Do what?
Is passing as a reference possible in Python?
Not unless we do arrays. So when we pass arrays, Python will automatically do that as reference, but they don't have any syntax for us to be able to specify that. That again is why it's such a hard concept for us. We have to really be thinking about passing by reference. It's just passing that same memory location. And we do that with arrays because, and we're going to start on arrays, we could have 1 million entries. So we don't want to copy that whole array to pass it to a function. So when the Python developers developed Python, they said, we will only pass memory locations of arrays. All other variables we'll make copies of and pass them by value. So it's just kind of, again, as things have evolved in our field, we work in a new field. Programming is new. It's only been around, 50, 75 years. That's very new. So some things are still developing and evolving. And passing by reference is one of those things that's kind of going away. So we'll still see things about it and talk about it, but it gets harder and harder to really get a handle on. So in this example, they're saying we change the value of num1 and the value of num2 in this math subprogram. But whenever we return from this program, the only thing that's going to be changed is the variable that was passed by reference. So that's a. So no matter what the value of a is that we pass in, when we get back from this function, the value of a is going to be 5 because this function changes it to 5. Now, the value of b will not be changed because it is not passed by reference. So we'll end up with b, which is 20, divided by 5 equals 4. So good job. And again, just remember passing by reference is a memory reference, memory location, memory reference. I guess it's kind of like if you had a friend who really needed a car. It would be so much safer if you can just make them a copy of your car and pass them that car by value. Say, here you go, you can use it, whatever you do won't affect my car because you're working with a copy. When passing by reference, we're actually handing them the car and saying, you go ahead and use it, whatever you do to it, I will suffer the consequences when you come back because I'm giving it to you by reference. I'm giving you the actual car. Go back and listen to that video over and over. Drive ourselves crazy. All right, the items listed in a call statement are known as arguments. Good job. Since the absolute value of -5 equals 5, and the integer value of 5.3 equals 5, these two functions can be used interchangeably. That would be false, right? We saw that looking at our built-in function display. The to upper converts all characters to uppercase. Good job, everybody's getting it. In a program with nested loops, the outer loop is completed after the inner. The statement, if the integer value of a number is not equal to a number, then what's this checking for? It's checking to see if the number is an integer or a whole value. Ooh, lots of fill in the blanks. That's why grades are so low, so don't worry about that. I've got to get all these graded. My bad, I did not realize that we were on this one with so many. The expression random times 6 taken to a floor can produce the numbers 1 through 5. A blank blank diagram, data flow diagram, keeps track of the data passed between our modules. The string 6.9 is stored in memory by placing the ASCII codes for 6, the period, and 9 in, and what they're looking for is contiguous. That'd be a hard word to spell, so continuous, adjacent, side by side, right? But the actual correct term would be contiguous. We don't want anything in between them. Everybody's got it. Okay, this one got some people. Here we're calling dress up, and we're going to pass in our sandals, our turtlenecks, and our jeans. And we're going to receive that in our subprogram as shoes, shirts, and pants. Now, where are the arguments? The arguments are here when we're calling. So the arguments are the values we pass. The parameters are the values we receive. The round function and the int function can do exactly the same thing. No, good job. A couple people had this one. This one again, we're just changing the value. So Z is being passed in as A, so the first number printed would be 20. So I don't have to go any further, right? Numbers that form an unpredictable sequence in which each number is equally likely to occur are pseudo-random or random numbers. I'll take either one. Same thing. Not exactly the same, but our book is kind of vague about it. So what's displayed? Oh, everybody got that one. Good. Now again, this one makes you go, what, 1, 2, 3, 4 loops out to determine what the correct answer is. And that's pretty unusual for programming exams. Usually you'll be able to kind of tell what the correct answer is after you've stepped through the code a couple of times. And whenever you're looking at pseudocode like this, you can convert that to Python and execute that code if you like to get that absolute answer in your mind of what that's going to do. Step through it on that visualizer website so that you can see it running step by step to see how the values change. Now, this is a really important one. I don't know how everybody did on it, but if a variable is declared both locally and globally, it is treated as if it were two different variables, and the local declaration always takes precedence. It's like pandemic rules, right? Our local Springfield ordinances, if they were more specific, would take precedence. But apparently not if they're looser, right? The number and type of arguments in a call statement must be the same as the number and type of parameters in the corresponding subprogram header. The function that converts the string yes or yes to yes is lower. Good, good, good. This one is kind of a little tricky, but no, a subprogram does not have to return a value. It might just do something meaningful like print out a heading or a welcome message. Call statements that pass values to a subprogram contain the subprogram's name and in parentheses a list of arguments. You'll see a lot of use of those terms interchangeably, but it's hard to get specific. We have to kind of look at the specifics of each textbook too. Sometimes there can be a little variation. To solve the problem of how to code a repeated multiplication problem, like that one they gave us, recursion must be used. No, we could just have a nice loop. Recursion is actually kind of expensive, right? The terms appearing in a subprogram header are known as parameters. And lastly, do drop in here. Let's see what we've got. We've got variable motel as a string, interstate is an integer. We're setting up our values. Then we call our vacation subprogram, passing in our motel and interstate as arguments. Whenever we reach our subprogram, we say, oh, I was expecting a string and a string. Now, again, we haven't seen this in Python, but we could make this happen in Python. If we had a string and Python was expecting a number, it can be a little bit more difficult because Python is very forgiving about these data types and it will just change things for us. But if we're working with a programming language that is not, we cannot just read in that integer as a string. So type mismatch. Very good. Questions? Phew, that one's a killer, huh? You guys did good. Work to get it graded. Everybody okay? Cool. Let's go look at our modules for this week. Food. I want food. I didn't eat, but you. This week, I'm calling it week 13. Not sure. I think that we're much further along in weeks because we only have this week and next week. So I'm going to look at this as a student and make sure that I can see all the things that I hope you guys can see. I might have to complete a lot of things to see those. Nope. Don't have to complete anything. We don't have that stuff at the end here. So we're looking at arrays, lists, and we've looked at them just a little teeny bit. We've used them a little bit. We'll use them a little bit more. There is a Runestone Academy list content assignment. So it's pretty minimal. Let's take a look at it. Well, that's helpful. I will double check that week 13 assignment, but it should be the Runestone information on lists. Then the assignment, the name array program, I've seen people already turning it in, so they've got these arrays well in hand. If you don't, that's okay, we will. This isn't due until Thursday night. We're gonna write a program that prompts a user for their first and last name, displays the length of the string in the full name array, the number of letters in the person's first name, the person's initials with a period after each initial, the person's last name. So we've done one that's somewhat similar to this in the past, huh? Shouldn't be a killer here at the end. And then next week, we'll glitch an image. Notice that one is due May 7th. The object-oriented programming, we might have time to take a look at that. That's not something that we have any assignments about, just some concepts that we'd like to take a look at before the end of the semester, if we have time. Now, your final exam is kind of interesting. First of all, use the unit exam practice tests for practice tests because we'll be using that same question bank. So do make sure you get to feeling good about those random number questions, like I said, and all of those coding syntax ones. So our final exam will be open for the whole week of final exams for online classes. The hands-on final is a little different though. I'm going to click on this to look at the information about it. The hands-on final for your final is actually bonus points. Chelsea, for your final hands-on, let's try to work on your own. That's a great question. I've wanted you to depend on your group, so if you get super stuck, reach out to them. But because this is going to be bonus points, just kind of try to focus on your own as much as possible. So it's totally bonus points. It's actually optional because we're here at the end of the semester, and I want you to decide how much of a challenge you would enjoy. So we have some different options. Again, you don't have to do any of them, but I would recommend that you do them. Or one is all you can do, because they're just going to be points to be added to your final exam. So if you chose option 1, you'd be using that turtle program to make like an image, make some sort of image for me about using turtle. So there's lots of examples online. This link shows you some directions to using turtle. We've used it just a little bit. You've used it in some of your Runestone activities. So that turtle assignment will just give you 10 to 20 points. So depending on the complexity of your turtle program, depending on maybe how often I've seen something very similar, that will decide how many points you get added. Now, option 2 is a little different. In option 2, I want you to think about having a golf game. So in our golf game, we're going to have 2 players, and there's going to be 18 holes in golf. And we'll use an array to hold the scores for each of the players. And then for each round, each hole, the player's number of swings will be determined by using a random number. If one player has fewer swings than the other, they won that hole. But we're really just interested in the total score. So we want to print out of each player the score they got at each hole, and then the total to know who our winner is of our golf game. So that one's a little more challenging. So that one would be 25 points for successful completion of that program added to your final score. And then the third option is just a little different. In this option, I want you to think about, oh, Chelsea, yes, quiz, you can refer to study group notes. So be sure you're getting those updated. Thank you. Our third option then is a player's strength. So I want you to think about it as kind of, again, like a quest. So you're going to offer the player multiple strength items, and you're going to let them pick strength items. So 2 players, each of them get to pick 3 items from the strength array. And you can kind of implement that however you see fit. It's kind of open-ended. Let's look at this first, okay? So when you're using the player strength assignment, again, if it's successfully completed, we'll give you 25 points on that final. So first, are there any questions about these hands-on assignments? It's up to you.
There, I found my mic button. I was looking at your cursor. Yes. So just to clarify, it's option 1 or 2 or and 3, or option 1 and then potentially 2 and 3.
Just one of the 3.
Okay, so we pick one of the 3. We can't do multiple. So it's
right. Just one of the 3.
Okay.
So pick which one is the most interesting to you. Some people I've known, like over the semester, they were worried about time. So I've seen some people like do a turtle thing and then work on option 2 or 3. But I would just pick one and focus on it. So you're not, you
And
know,
they just use a simple turtle to fall back on in case.
yeah, in case you run out of time and you just want to get something turned in.
Understood.
Oh, nice. Isaiah's going to control the ball. Awesome. That sounds awesome. Isaiah. Combine them together. You might not, though. Okay, we'll leave that option open.
Yeah, that sounds like a lot of work.
And then, yeah, RJ, it can be any sort of item that you want. So, like, you could have, you know, a sword or a shield or, you know, a car and a house, whatever kind of strength it is that we're thinking about, because it's a totally wide open. So whatever you think. And then Chelsea has awesome questions about the written final, which are very important. Let me get back to them. I don't know if you could calculate the ball's movement with turtles. I don't think you have force, but you might. Okay, Chelsea was asking great questions about the notes that you guys have created. You can use the notes you've created over the semester. I think that's your reward for doing such a great job at creating your notes for your study group, that you can use them for the final. Some of you guys I know have just created some outstanding notes, and I'd like you to benefit from that. Perfect. Anything else? So no combining. Only one of the hands-on assignments are allowed. You can, of course, add complication if you want to, depending on the level of complication. You know, I could give you more points. But remember, this means that, like, if you get a 75 on the final exam, the written test, and you do option 2 or 3, that's going to give you 100% on the final exam. So let's talk about arrays. We got to do some array stuff. You know what you could do, Isaiah? You could almost come up with a random number, you know, is the ending location, and just move the ball to that spot. So you wouldn't be using like any sort of physics, but just a random location. Chelsea's asking about references for the hands-on. You can use code that you have. And for option 1, you can use not only that link that I've supplied, but you can also use the Runestone Academy for reference, because we don't have a lot of sample code with turtle stuff. So you definitely need to refer to the web for that. Good questions. Any others? So yeah, we're getting close. Let's see. Got a calendar here. But this week we have class whips on Thursday, and then we have next week, and then the following week we will, like I was talking about, do some of the object-oriented programming concepts. Next week will be our file handling and working on glitching our image, object-oriented programming, and then we'll start with the final. So you can start working on it anytime, but we need to do this array handling before you're going to be comfortable with it. So in our modules for this week, I actually have downloaded both of these presentations because I think that they both have a lot of value. So I'm going to start with this second one, the array structures. If we're ready. Does anybody have any other questions or thoughts before we do that?
No, we're okay.
You're okay? Thank you. All righty, let's do this. Find my mouse. Now, like I mentioned, some of you have already turned stuff in. You're so on top of it. Some of you have no idea what an array is. That's okay. We got this. So an array is a collection of stuff. And we, in our textbook, you'll see that they also refer to it as a table, which is a way throwback. So that's a really old term to represent an array. So what is an array? Well, an array is just a variable that holds repeating data. This out of my way. Yeah, Chelsea, anytime during that finals week, you guys will have more time since we're sort of online. So anytime you'll be able to take it. Now, when we're working with an array, we are being able to more efficiently save our information, but we have some rules. First of all, an array has to be allocated before it can be used. We have to tell our programming language that we are going to use an array structure or a list structure. So first of all, let's think about some of the variables that we've seen. We've seen, integers and strings and floats, Booleans, lots of different data types that we've used. But what if we want to keep track of more than one name? We want to keep track of all of the people in our office's names. We have Joe and Bill and Tammy and Vera and Austin. We can set up an array. So in Python, if I use this syntax where I say name equal square bracket, then Python knows that name is going to be a list or an array of values. When I put some values into my array, we'll see how to do that. But say I've got these 5 values in my array. These are the different names. Now, each of these names is an entry in my array. And so that I can differentiate the different entries, I have an index internally associated with each of those entries. So my index is just an integer, and it's used as a pointer into the array. So my index always begins with the value 0. So this array has 5 entries, index values 0 through 4. The index value for Tammy is 2. So if I wanted to refer to that specific array entry, I could refer to name with a 2 within the square brackets. So name at index location 2. Now, if I want to change the value, I could say name at index location 2 equals this new name, and that would update that array entry. Index still the same, right? But now that data value is different. So our index, our pointer, is internal. We don't assign that, the system does, but we can use it to specify which array entry we're referring to. So what if I have an array that I want to keep track of people's ages in? In this example code, I have my age array, and I've gone ahead and preloaded some values. 1, 45, 29, 24, 14. And then I can use that age array to print those out. Let's write that code. I've got Adam open here. And I'll let you get it open so we can create our own array code. I'm going to create a new file. And let's see, I'm going to name this. This is actually chapter 7, which kind of puts us back in time, but to keep it organized, I will do that. So let's call this array example.py. And remember, when I'm using Atom, I have to put in the .py. It won't do it for me. So here's my example.
What were we calling this?
Chapter 7 array example.py. So I'm going to say that in our name. Doesn't seem to think I'm using Python here. Getting some definite weird stuff. That looks better. Was just waiting for those last 3 quotes, and I'm blinding you here with my weird atom skin. Feel all matrixy with this black screen and this neon green text. It'll only be that way for the comments, don't worry. Okay, so in the presentation, get back to it, we wanted to put this code right here. So I'm going to say age equals 1, 45, 29, 24, 14. So that's my age array. And I could also refer to it, as a list in Python. Now, if I want to print out some of those ages, I could just say print age, and that would print that whole list. Let's try it. Notice it prints it with the square brackets and everything, just like I have it in my code. So that'll print out the whole array. But what if I only want one entry? I can say I want the entry at index location 4. Which one's that going to be? 0, 1, 2, 3, 4. That should be that 14. Let's try it, make sure. Yep, there's that 14. What if I print age at index location 0? That should be our very first one, the number 1. Try it. That looks good. Lastly, what if I print age at index location 5? 0, 1, 2, 3, 4. It's invalid, isn't it? Let's see what happens. What does Python do if something like that occurs? It crashes. And it says,
Index error, list index is out of range.
yep, it's not in a valid range for our array. So whenever we're doing it intentionally like this, we know what's happened. This kind of out of range error usually occurs if we're in some sort of loop. So it might be a little bit more difficult for us to figure out why it happened. But if I were to approach this array with a negative index, I would get that same error. So anything that's not valid. Got it? So I'm going to minimize Atom here again. So we see that we can't do that. So here's what this looks like internally in memory. You saw that first one where I listed the name array and I had it kind of top down. And here we're listing our array entries side by side. This side-by-side arrangement is more what it would be like in memory, because array entries must be in contiguous memory. So that means if I say this array has 1,000,000 entries, I'm going to take up, you know, a meg of storage for every character that I carry in each of those entries, right? Because I said it's 1,000,000 entries, so it's going to be about a megabyte. And so I could easily start eating up memory. So I have to be careful with that. That's where we start using databases and things like that so that we don't have to have all of those things in memory all at once. Now, looking at this, if I look at the way this array is set up, there's an error. Let me fix it. Look at that. Can't believe it. An error. That should be a 1, huh? Can I even fix it? Not that way. Try that again. Probably pops up again in more places. So we have our age, and here's what our array really looks like in memory. So I have all of these data values that we put into our array, and then we have our index values that point to each of those different entries. Again, it's contiguous memory, has to be side by side. I can't have other stuff in between entries of my array. So my index values are shown here across the top, my data values. Now this array is being initialized in the code. We're giving it the initial values. When we do that, we start with the name of the array. Our initial values are within square brackets. They're separated by commas. And those values are used to determine the size of the array, right? Found 5 values, that array is going to have 5 entries. Now, whenever we want to access that one array entry, we always use the array name, age, followed by our index pointer, which is within square brackets. And then the variable that we're using, in this case, one age, is going to be set equal to the value found in our age array at index location 3, 0, 1, 2, 3. Now, if we want to update that entry, just like earlier, we're going to say set the array variables at this particular index equal to this value. So our array name, our index pointer that's within square brackets, is going to be set equal to that new value. Okay, whenever we have an array, it's common for us to have to loop through the array or walk the array or traverse the array, depending on who we're looking at. So let's try this for loop in our array code that we have in Atom. We already have all of our prints here. So let's add it after. We're going to say for, and in the sample code, they say a thing. We can do that. Thing in age. So that means for each item in our age array, print thing. So whatever we call it in our for loop is how we're going to refer to that entry within our for loop. Let's run that. I think I'll put a print statement before it though. say something like for that's better. No, let's try that. Oops, I still have that bad print in there. Got to get rid of that one, huh? Comment that out and say this is out of range. Now, we see our beginning print output, and then our for loop beginning message, and then we see for our for loop, we're getting each entry in our array printed out on its own line, separate print statement. Okay, so our for loop will let us traverse or walk the array and process each thing in our array, each entry. Now, whenever we're using a for loop like that, it's going to start out with our first entry. Watch this animation here. And then it's going to give us our second entry, and then our third entry, fourth entry, and finally our last entry. But as we're processing the for loop, what I want you to notice is we really are not seeing that index value, right? Our for loop is not showing us what that index value is, just the value of the entry. That's important because if we need to know what position some item is within our array, we're going to have to take care of that on our own outside of this for loop. But it does a great job at just showing us each item in our array. Whenever we're using a for loop like that, the syntax is for, it's really a for each loop. And then we're gonna, whenever we're using a for each, we end with our colon because we know in Python, any statement that has a body or indent underneath it ends with a colon. The in is actually a required word. After the for and before the in is the name that we're going to assign as a variable to hold each array entry. And then finally, after the in keyword is the name of the array that we want to process. So those are our rules for that for loop. Now, sometimes we need more information. We might need to keep more data than just the employee's name. Maybe we want to know the employee's name or the teammate's name and their age. We can actually keep a parallel array. And a parallel array is where I have two different arrays, but I keep them in sync. So entry at index location 0 in both arrays has to do with Joe. So in the name array, it's Joe's name. In the age array, it's Joe's age. Entry 1 in both arrays has to do with Bill. We have Bill's name, Bill's age. So we just keep all these entries in sync. We call that parallel arrays. So we can kind of think of them as related, but they belong together. Now, in Python, we're using Python lists. So it's not really just an array like it is in different languages. Different programming languages do different things internally. But we're going to use these, and these lists allow us to take care of these repeating data elements. We have that happen a lot. We can efficiently handle arrays in loops, and the for each statement lets us really easily process all of the entries in an array. we're going to be able to create programs to work with different data types and different values and different conditions. And we have different kinds of capabilities and flexibility in Python than what we would in a different programming language. So that's good. We have our example that we've been working on. Now I want to look at this textbook presentation. And don't worry, we get some code right away. So like I said, in our textbook, they just name the chapter with every possible name we have for an array. Well, almost, because they left out collections. But we have arrays, lists, and tables, collections. All of these things are pretty much the same thing. One thing that's not, though, is a table. A table way back, step in that go back machine, was an array, an early array. But then databases started using that terminology, table, to refer to information stored for a specific entity. So we don't really use that term when speaking with arrays, but we use that term when speaking with databases. And our textbook's going to throw a little bit of database stuff at us, so that's okay. Those arrays that I was showing you were one-dimensional arrays. They just had one entry. It was related data type like names. So again, an array is just elements. And here is the same kind of information about our index. One thing, index could also be referred to as a subscript. So again, that's a little bit of older terminology. But I might say it too whenever I'm talking. So I could say, oh, we have an array named scores, and scores sub 3 in my mind is scores with a subscript value of 3. So that's the same as saying scores with an index value of 3. So I would say that. Now, in our example, we actually created our array with its entries. So we didn't use anything to input our entries. Let's see if we can update our program a little bit to prompt a user to input. So let's do this scores array. So I'm going to bring Adam back up. And I'll comment out the stuff that we have so far. And now we'll try to do some scores. Now we saw that for Python, we have to say scores equals square bracket to tell Python this is going to be an array named scores. They want a for loop, so we can do that. For k in range, they want to start it at 0, go to less than 25, and add 1 for each entry. And then we're going to say that we want to have our user type in a score. I'm going to change it just a little bit. User data equals an integer from our input, and the prompt is going to be enter. Then we can say we want to update our scores array to add that user data. And I want you to see a little bit of difference there. Whenever we're looking at the pseudocode, they said, oh, we're going to just keep updating K, right? And each time we update K, we're going to use it as the index to update the value of our scores array. So if K was 0, we would take the data that the user entered and input into scores sub-0. For Python, we have to do it a little different. We can't do that with Python. Python won't let us access index location 0 until we actually have an entry in that place. So we have to use the add function. So same difference, just a little bit different syntax. So let's use our K variable somewhere in here so that it makes a little bit more sense to us. Right here in our input statement, let's enter score plus K plus our colon. So now we can say enter score 0, enter score 1, enter score 2, and that'll work for us and we'll know what we're doing there. In our sample code in our textbook, that's all they do is the input, but let's go ahead and print our scores array when we're done so we know what it looks like. One last thing. I don't want to enter 25. How about you? Let's do 5. That'll be much better for us to handle test-wise. So I'm going to press F5 to run this. And it's mad at me. Let's see, type error in my input statement must be a string, not an integer. So I need to convert K to a string. Try again. Here we go, enter score 0. Oh, look, I just lied. Well, how do we do it? Let's go Google it. Let's see, I have an array. I'm using Python. Add element. That's what I want to do. I saw Google suggested it. I thought that was a good suggestion, Google. How can I do that? Doing something wrong. Oh, let's see, append and extend. Anybody see a spot they like? Here is Google. Looks like I need to do append. Are you getting that impression? Append instead of add? Let's try it. Huh?
We should try append instead of add.
Let's try it. Ah. And it's coming up in Adam saying, oh, that's a good idea. I think I changed to developer mode is why I'm getting these weird messages in Adam, if you're curious about that. I will turn it back off because it's kind of distracting to our code. But I want to try this now. So append is like add. It just means take what's already there and add more to it. So we can handle that. Now I'm going to enter a score. Oh, that looks better. And there's our whole list. So we've got all our scores entered now. We just added each one to our array within our loop. Everybody's good?
Mine is not.
What's the matter?
Hang on, let me run it again. Yeah, it still doesn't like the scores append.
Here, let's see what you got. Share for us.
Okay. So many tabs open. Okay.
I know what you mean. I'm just looking around trying to find it.
There we go. Oh, it does not let me see what I'm sharing. Okay. I'm not using Atom because I have recurring problems with it.
That's okay.
I have not had time to fight with it.
That is fine.
So anyway, F5 it. It'll allow you to give the first score, but then it does not want to put it in the array.
So I see it says name SOCRES is not defined. Do you see a typo somewhere?
Ah,
Do you see it?
yeah, that's the part.
Beautiful.
There we go.
Cool.
That looks nice. And you know, sometimes I look at idle and I'm like, I like idle too. Until it crashes. Thank you. That looks great.
Give back the screen.
Let's see who else we got. Oh, thanks, Steve. You just sent that out. All right. So we saw we can just add to our array. Super easy, especially in Python, because we don't even have to worry so much about what that index value is, because they have just functions that we can use to take care of that for us. Now, when we declare an array, just like we were looking at earlier, we're going to determine in a lot of languages the size of the array at the very beginning, and then it's going to be allocated out. Python is a little bit more efficient in how that's handled, in that it allows us to add more entries to our array using the append command. If I were using other languages like C# or Java, I would not be able to change the size of the array once it were allocated. I would have to do other types of logic to take care of that kind of problem. But whenever we allocate an array, the system decides what data type is going to be stored in the array and how many elements it has. If you notice the examples that I gave you, we had all strings in the array or all integers in the array, and that's common with Python. Of course, we can be a little bit more flexible. Okay, let's try this one. Here we have weekly sales for just basically kind of the same sort of thing as what we were already doing. So let's see if we can switch that in Atom, input loop. So I have prompt for scores here. I do a little bit more and prompt for weekly sales. We don't have to worry too much about using this K as an integer. We can again allocate our array. It's an empty array. We can enter our for loop saying we want to use K. We're going to start at 0. They want to do 52 weeks of the year. We don't want to do that many. How about 7? And we're going to increment that by 1. So we're going to have a temporary variable user data to hold our user input. And we'll do the same thing. Now for this example, let's go ahead and add 1 to our K value in our output message so we don't ask for week 0. And then we'll add our colon. So we're saying we want to prompt our user for sales for the week. And then our weekly sales array, we're going to append that user data. When we get done with our for loop, let's print our weekly sales. So first, scores. And then our sales. And so notice how, since we added 1 to our counter variable, we have kind of a better message for our user. Sales for week 1. And then we have all of our sales information. So we see lots of ways to get data into our array. We can have an initial value given it when we create the array. We could prompt the user for data. We could put whatever data we wanted to into our array. So next time, we'll look more at using the array in processing, making sure that we can manage the information that we have in the array. We'll set something up where we have parallel arrays that we're using side by side and a 2-dimensional array so that we can keep track of more than one type of information. Questions?
I have one.
What's that?
So updating a single array at a time seems to be fairly limited to mostly technical things. Most of the instances I can think of where it would be good to use this, the user would need to input multiple things at kind of at once. So for either example, we'll go with the scores. So we've got in the original example 25 students, but we're only putting in 25 scores. There's no association. How do I set that up to associate each score with the student who has that score as I'm going? Does that make sense? I don't want to do 25 numbers and then 25 names. I want to do a name and a number, or a number and a name.
Right. So we would prompt, like in our example where we had the person and their age with our parallel arrays, we could say, enter person's name, and then we'd stick Tom into our name array. And then we could say, enter Tom's age, and we would put that into our age array. So we can handle that. But in reality, we would probably keep that information in a database. So we're kind of in that, like that in-between area, like the Twilight Zone, where we're learning stuff that we might not use as often as we would use an actual database. So we're getting there. So where we would use arrays a lot in processing things are for like monthly sales. That's something that's really common. You'd see in a lot of programs where they would set up an array with 12 entries and they would just add every invoice amount into the appropriate month's sales. Does that make sense?
It does. I'm just thinking about the user interfacing. So like if we want to prompt for 12 months worth of sales, I would want to set each of my case to those month names in some way so that my user understands. That way they're, as they're looking through the paper, adding up the weeks worth of sales for each month, they don't accidentally enter April in twice or skip months around and get bad data.
We could do that. Let's do it really quick. Let's put it right in this one. Here we've got our weekly sales. Let's say, this is monthly. And I'm going to leave everything named weekly sales because I'm lazy at this moment. But we're going to set our month equal And then I'm going to say that I only have 4 months. And then when we're outputting our prompt, instead of saying enter sales for, I'll make that say month so it's not confusing. I could actually, right here, use my month array, subscript K, case K, and then it's going to use the value of K is an index into this month array, and we should get sales for month of, when K is 0, we should get Jan. Let's run it and see. We're about out of time today, but we'll look at it more next time. Okay, so now here's the prompt that was actually impacted by our changes. And we see that we're using our month array to build the prompt. So since our K counter is set to 0, we see our month name of January. So we can use multiple arrays as we're processing information. And a lot of times our counters will be set so that things will work in coordinating the 2 different arrays.
Fantastic. So then you would just create under the K within your for loop.
I'm in the middle of my Zoom session.
Beg pardon? I think you meant to be muted. You just do a second input. So like for scores, your first input under user data, that variable would be a request for input for student name, and then directly, and then you'd append it to the appropriate array. Then you do it again with a different variable name, different array. So then you've got name, score, and then at the bottom you could print name, print score.
Exactly.
Okay, fantastic. So it is as simple as it seems. It's just a matter of chaining it together and making sure you just plug them just right. Oh,
yeah.
Cool.
Yep, it is. Any other questions? Because you're so good. We'll look at it more next time. We'll continue on. The presentation actually has a lot of really good code snippets like this that we have to convert a little bit to Python, but I think they're good for us to look at. So, all righty then. Let me know if anything comes up. Otherwise, I'll see you Thursday. Is there a remove number? Yeah, and we'll look at that. Next week, we can get rid of entries out of our array. So don't let me forget, if they don't do it in the textbook, we might have to physically go do that ourselves. Other thoughts?
No, I think we're good.
He's good. Isaiah, I think we'll have to try it and see. Such good questions. Because I think it's going to keep the same address except for the one that you remove, but we'll have to try it.
Yeah, that raises an important question if you remove an entry in the middle of the array, because you said they had to be contiguous, correct?
Right.
So then it would crash the system if it doesn't shift everything back.
Yeah, exactly. So we'll try some, because it should, I'm not sure if it would rebuild the whole array to where you would just have contiguous entries. We shall try it. Good question. We see what happens.
All right. Thank you, ma'am.
Thank you. Any others? Got it? Good. Okay. See you Thursday. Bye.